Hello, good morning. Uh, this is the session 19 of the elective paper in which we are discussing the electrical appliances, working principle of the electrical appliances. Say today I'm discussing the so-called fluorescent, that compact fluorescent lamp, and then the LED. Okay, so my main focus is what is that CFL bulb and what is the advantage of the CFL bulb, and how the CFL bulb is different from the incandescent bulb. So this I am going to discuss, and thereafter I am going to deal uh, the most familiar and everybody knowing light emitting diode LED, its constructions and its working, and sometimes its applications if it is there. So that was my today's discussions flow chart. Okay. First, I am discussing the compact fluorescent lamp. So, in general, it is called the CFL. Everybody is having it in every house. Okay. So, it is nothing but an electric discharge. Okay, discharge tube. It's simple. An electrical discharge is passed through mercury vapor between the two electrodes. So, in a compact fluorescent lamp, an electric discharge is passed through mercury vapor between the two electrodes. So, what happens? So when electric discharge is passed through mercury vapor, that electric field which is established, the with electric field established in that region causes the vapor to emit ultraviolet, invisible ultraviolet light. So in the compact fluorescent lamp, actually what we are doing, electric discharge we are passing through mercury vapor between the two electrodes. So because of that, what happens? The electrical field established there makes the vapor to emit the ultraviolet light. So that is important. But inside the bulb, we are painted, the better word, the sprayed, the fluorescent material which is applied inside the glass tube, that converts this ultraviolet light radiation into visible. So that's the basics. Okay. So electrical discharge is passed through mercury vapor, and then that electric field makes the vapor to emit the ultraviolet light. The fluorescent material what we have pasted or spread or applied inside the glass tube convert this ultraviolet radiation into visible light. Okay, so depending upon the type of the fluorescent material we applied it, a light of different colors can be obtained. That's all simple. Okay, the very important factor is the overall length of the CFL is reduced by bending each tube back on itself. You just observe the normal tube light, it is a long, so here the length can be same power or the same intensity can be obtained by just bending the tube. So this is one of the important application or important part of the compact fluorescent lamp, in short CFL. See the main advantage, see this is what you have seen in your house, the fluorescent. See this is what I am saying, the tube is bent, tube is bent, look at here, it was twisted. Okay, the main advantage of CFC, provide direct energy savings. So this is very important. So compared to ordinary incandescent bulb, you can save 70 to 80% of the electricity when compared to the normal. This is the greatest advantage. And then there is no there is no flickering. That means it, when you switch on, it instantly starts. It doesn't take some time. Okay, so it provides a flicker free starting and the flicker free operations. And then this provides it's a compact, very small. So instead of using the big tube, you can save spaces. A very small region is sufficient. Okay, then average lifetime of the CFL is about 8 to 10 times more than the, in the at normal incandescent bulb, it's around 5000 to 7000. So now you can 1000 hours. So this CFL you can use it for more than 10 times or more than 8 times. If it is 5000 normal incandescent bulb, 8 times more. 8 into 40, that is 40,000 hours you can use it. So this is one of the important applications. Okay. Then you should be very clear uh, how the CFL is different. Okay. The one important is light intensity obtained in the case of a CFL is 40 lumen per watt, whereas in the case of normal incandescent it is 10 lumen per watt. So therefore it is a cost effective. So lesser power, more brightness you can obtain it. So light intensity obtained for every watt of electric power is 40 lumen per watt, whereas in normal incandescence it is 10. So lesser power you can obtain more light and no glare or glitter effect. See, when you are observing, when you are using the incandescent light while writing, so the hand shadows something like will observe. And if you observing the incandescent bulb directly and try to observe the other part of the your domestic house, then you will see uh, something like glaring effect is observed. So that glaring effect is not there in the case of a CFL. And the heat produced in the case of CL naturally very less. Uh, the only disadvantage I can say is the initial cost is going to be very high. The normal incandescent bulb, if you're getting it for 40, and it may be around 80 or 90 like that. So this is one important. And the lifetime of in CFL bulb is very large, as I said in earlier discussion, 8 to 10 times when compared to normal incandescent. As I said, if the incandescent bulb you can operate it for 5000 hours, and the CFL bulb you can use it for 10 times, that is 50,000 hours. That's what the benefit. Okay. Now we'll discuss in brief about the light emitting diode, or in short LED. Now it is common everywhere. You can see here, this is the diagram, light emitting diode. So this is the flat portion, anode and cathode. So like this marking will be there. It's a circuit electrical symbol. And this is, if you cut this, the partial view is appears to be like this. So actually it was the inside the working is like this. So it is essentially a PN junction opto semiconductor that emits light when operated in the forward direction, forward bias direction. So when PN junction is operated in the forward bias junction, this special diode uh, emits light. So it's a PN junction opto semiconductor that emits light when operated in a forward bias direction. So LED converts naturally the electrical energy into light energy. The most important part of the light emitting diode is the semiconductor chip. That's important. Located at the center of the bulb as shown here. So this is the very important part. Semiconductor chip that is placed at the center. So we'll discuss this in detail in the next slide. You just go through this. How is that chip? This chip has two regions separated by junctions. You can see here the chip has the two regions separated by these junctions. Okay, junctions. Chip has the two regions separated by junction on a substrate. See, this is the metal contact on which there is a N type of a semiconductor. This is junction. This is the P type of a semiconductor. Okay. Over this P on substrate N type of layer is. See, this is a metal substrate. N type of semiconductor is grown. Above that, the P type of semiconductor is deposited by the method of diffusion. So this P region, as you know, contains more holes. The N region contains the more electrons. The junction produced because of this diffusion of electron from N region to P regions. So that forms the PN junction. Okay. So this PN junction, once formed, it further opposes the migration of the carrier. This you will study in detail or you already studied it. Suppose a sufficient voltage is applied to the semiconductor switch, then the electrical current can flow through this, and the electron from here crosses over the junction into the P region. So if you are applying certain forward biasing voltage, that means the N side connected to negative of the supply, P side connected to positive. After certain voltage, that's called the cut-in voltage, this electron from the N side enters to P. Okay, so this is the normal operations. So during these operations, the normal operations of the PN junctions, the electron hole recombination takes place. That's what here. Okay, P region, LED is forward by in its normal position here. During the forward bias, here I have written electron hole recombination takes place across the junction. So this is important, and because of this electron hole recombination, the light is emitted. This is very important. Okay, during the forward bias, electron from emitter enters to the P side. So this electron and hole recombination takes place across the junction, and that energy release will be in the form of a electromagnetic radiations, or normally the light. Okay, in P layer, electron hole rock takes place and light emits through mid in the top. For each combination of the positive and a negative charge, a quantum of electromagnetic energy is emitted. That's what I said it here. Okay, and the dome what we are placed at the top of the LED. Look at here, the dome here. This is the dome we are mentioning. So this dome is acting like a lens, and it diffuses the light. So that's all the simple one. Okay, diffuses the light. So here mainly the electron hole recombinations. That's very important. Okay, the very basic is you cannot use LED to the direct source, because the power may be very high. That is the too much current surely going to destroy the LED. Therefore directly we are not connecting the LED to the source, but a limiting resistor is connected at least of 1 kilo ohm in the path of the LED before connecting to the sources. So as you know, there are many applications of the LEDs, the pilot lights, digital readout devices, image sensing circuits, gallium arsenide in high radiance in optical communication, infrared LEDs are used in burglar alarm system or remote sensing. There are many, you know, that using indicator in batteries and the power supply. So these are some of the applications. The very interesting factor of the LED is they are directional light sources, emitting light in a specific directions. This is important. Whereas in incandescent and the CFL, the light will be emitted in all direction, and the heat is also there in all direction. Incandescent, light, heat in all direction. Heat is more. CFL, light is more, the heat is less. Whereas LED, it is a directional. It will be emitting the light in one particular directions. LEDs are more efficient and versatile and possesses longer lifespan. This is important. Longer lifespan. Similar to incandescent bulb, LEDs does not need any warm up time, and they burn instantly. Okay, so immediately when you turn on, the LEDs are going to be turned on. Okay, so this is what the speciality. LED lighting produced light up to 90% more efficient than the incandescent. These are the common. The cost is going to be very less. The lumen per watt is going to be very high in the case of a LEDs. And this LED is small in size. You can use it for many design purpose. LED also finds very vast opportunity in developing the new technology in the traditional lighting systems. Okay, some of these ideas you try to understand, and you studied this in detail. You go through this. There are many material available, or in the future you are going to study this LED in detail. Thank you. I am going to stop at this time.